In the last video, we predicted the products of reactions between ionic compounds in solution by looking at how they broke up into ions when they were dissolved. A compound that breaks up into ions when it's dissolved or when it's melted is called an electrolyte. Now it can happen either when they're dissolved or melted. So electrolytes have ions that can move around. Now when the ions are in the ionic compound, they are locked into place like bricks in a wall. We drew the structure of sodium chloride a couple of times earlier. And you can see the positive ions are stuck really tight onto the negative ions and they can't move around. But when you dissolve them, you put an icy shell of water around it, or when you melt them, when you tear them away from each other, those ions can move. And they're going to conduct electricity. Now, electricity is really just moving a charge from one place to another. So anytime you have a mobile charge, a charge that can move, you can have electricity. So you can guess what kind of compounds are going to be electrolytes. You would guess ionic compounds. Well, the acids can be electrolytes too. There are basically three kinds of electrolytes. There are soluble ionic compounds. If they can dissolve in water, they will be an electrolyte in water. So it will have to be an ionic compound, which you can recognize as having a metal and a non-metal usually, and it will have to be soluble. So you have to look up the solubility for these compounds to see whether it's going to really make enough ions to significantly conduct electricity. If it's completely insoluble, it won't break up into ions. It will stay locked together. The ions will stay locked together in a crystal. Another type of compound is a strong acid. All right, what's a strong acid? A strong acid is something that breaks up completely. So an example would be something like HCl. Now suppose you got a beaker here and you throw some HCl in there. You are not going to see any HCl molecules. You're going to see ions floating around with their icy shells. And it'll look like that. So strong acid it breaks up completely. And in fact, almost all soluble ionic compounds do that too. There are a few exceptions, but you don't need to worry about those. These two kinds of compounds collectively are called strong electrolytes. Now, strong electrolyte is anything that breaks up completely into ions in solution. So since almost all soluble ionic compounds do that too, we'll include that under that umbrella. Now you can have some acids that aren't strong acids. How can you tell whether you've got a strong acid or not? Strong acids actually are pretty rare. And there are only 6, and you should know them. Can you name that one? Hydrochloric acid. What's this one's name? It's got a bromide ion in it. When you have an IDE ending, you say hydrobromic acid. This would be hydrobromic acid. HI. That's got an iodide ion with an IDE ending. So this is hydroiodic acid. There's a nitrate ion in there. So this is nitric acid. There is a sulfate ion in there, SO4 that is. And that's sulfate with an ATE, so you put an ic acid ending on the end. It's sulfuric acid. And finally, that has a perchlorate ion in it. So this is perchloric acid. These 6 you need to remember. I think your book gives you a 7th one, but I'm not going to have you memorize that because the 7th one that they give you is not actually stable. So these are the 6 strong acids that you're likely to encounter in real life. They are stable. All right. So if you see an acid that's not on that list, it will not be a strong acid. It will be a weak acid. So a weak acid does not break up completely into ions in solution. Alright, so if you've got a beaker here, and instead of putting HCl into it like we did up here, let's put HF. Now HF is hydrofluoric acid. It is a nasty acid. Even though it's a weak acid, it can dissolve glass, so you have to keep it in plastic bottles. Alright, it's not on my list, HF. It starts with an H, so I know it's an acid. And it's not on my list, so I know it's a weak acid. And what are you going to see when you throw some of that into water? You're going to see some hydrogen ions and some fluoride ions. It'll break up that way. But you will also see some molecules that don't break up. So you'll have ions, some molecules. Now, do you see the difference between this one and this one? Here they're broken up completely, and here they're not. You have some molecules in there. Now, molecules, being electrically neutral, cannot conduct electricity. So if you had a solution with 1 mole of HCl in it and another solution with 1 mole of HF in it, you would expect to see this one conduct electricity a lot better because there are more ions there. More ions, more conductivity. That's a way to experimentally tell whether you have a strong acid or a weak acid. Now, compounds that are like this, that don't break up completely, are called weak electrolytes. And the only weak electrolytes that you are really going to encounter in general chemistry are weak acids. Like I said, there are some soluble ionic compounds that are weak electrolytes, but they're fairly rare and obscure, and you don't need to worry about them. You can assume all soluble ionic compounds are strong electrolytes. Now, what happens if you have a compound that doesn't fit into these 3 classes? Then it's not an electrolyte. We call it a non-electrolyte. And this would be an example like a covalent compound, a molecular compound. All nonmetals. Here's blood sugar. Now that doesn't have metal in a nonmetal. There are no recognizable ions in there. So if it cannot break up into ions, it cannot be an electrolyte. And it will be a non-electrolyte. let's practice classifying a few things as strong electrolytes, weak electrolytes, or non-electrolytes. Suppose I have calcium chloride. Now that's calcium chloride. The calcium has a +2 charge, so, and the chloride ion has a -1, so we see ACl2. Is this a strong electrolyte? A weak electrolyte? Or a non-electrolyte? Well, it's an ionic compound. And if I go look it up, it's soluble. Now I will signal to you sometimes that you have a soluble compound by putting an AQ after it. The AQ automatically tells you it's soluble. So this is a soluble compound, and I recognize it as ionic because I can see ions that I know in there. There's a calcium ion in there, and there are chlorides. And if I go back a little further, I recognize it as an ionic compound because it's got a metal and a non-metal. So if it's a soluble ionic compound, it's a strong electrolyte. How about this one? Can you name this compound? What's the name of the ion that's inside? On your polyatomic ion list, that's the acetate ion with an ATE ending. So to name the acid that is made from an acetate ion, you put ic acid on the end. So instead of acetate, it'll be acetic acid. Is this a strong, weak, or non-electrolyte when you dissolve it in water? Well, it's an acid because it starts with an H. But it's not on your strong acid list. It's not one of your 6 strong acids. Not on the list. So it must be a weak acid. So it must be a weak electrolyte. How about SF6? I would call this sulfur hexafluoride. I'd use the hexa. I use the prefix because I recognize that these are 2 nonmetals. So sulfur hexafluoride, and if it's a covalent compound, molecular compound, it's not an ionic compound, so it cannot be an electrolyte. It's a non-electrolyte. So there will be some questions on your worksheet that will ask you to classify things as strong, and these will be either soluble ionic compounds or strong acids. Weak, these will be acids that are not on your strong acid list. Or non, these will be covalent compounds. There'll only be nonmetals in them.